Hi, I'm Javier Flores, and I am from the Universidad Politécnica de Catalunya. Today, I will be presenting our paper, Effective and Scalable Data Discovery with Next.js. This is a joint work with Sergio Nadal and Oscar Romero. So let's start. So let's consider that we have a reference data set composed by attributes and data instances, and we have a data lake with different data. So we would like to discover data sets in the data lake that can be crossed by means of a common attribute with the reference data set. This is a complex exploratory task that can be time-consuming since data lakes contain data generated independently, there is no schema provided, and data heterogeneity. Then we have a data discovery problem to find joinable data sets. So let's consider an example. So now we have a table about the stores located in the northern region of Spain, a table about average life expectancy per region in Spain, and a list of product names with reviews. And let's say we are interested to find joinable attributes for the first administration level. We can see that region and product share the same values. And to find joinable attributes containing similarity can be used, which is defined as the cardinality of the common values divided by the cardinality of A. So let's suppose all values from first administration level are contained in those attributes. But we produce a high similarity of 1, with just one is relevant to join, which is the region 1, since they represent a semantic relationship and they share the same real-world concept. As for product, it represents a syntactic relationship since they just share the common values, but not the same concepts. And this will not add any value to the discovery task. That's the problem of current state-of-the-art approaches, since they generate too many false positives to be filtered out manually. So note that the cardinalities are really different between the product cardinality, since it's 1 million, compared to 9 values from the first administration level. So we know that the maximum number of regions in Spain is 17. So other attributes with really bigger cardinalities might possibly refer to different concepts. This scenario is very common in data lakes, and the cardinality proportion can provide information needed to filter syntactic or semantic relationships as the product one. So we define a qualitative metric based on containment similarity and cardinality proportion. Using the cardinality proportion, we complement the discovery results to identify more semantic pairs of attributes. So we create 5 quality labels. The higher the quality label, the higher the containment, and the more similar cardinalities they will have. So our approach is based on data profiling at the attribute level, and we learn from these profiles whether they are joint candidates or not. Next.js takes full advantage of Spark to efficiently distribute the workload on very large data sets. We will compute cardinalities, value distribution, and syntax and relationships once we perform a data discovery. So to use attribute profiling, we will have to read the data set and call the method attribute profile, and it will return a table like this by attribute and the metadata that we obtain from the profile. So now, once we have a data profiling, we can start performing a data discovery. We will create a combination of pairs, and we will compute the relationship profiling. And we normalize the profiles, compare them, and use random forest to predict the joint quality label. So we identify 2 types of discovery. Discovery by data set, which search joinable attributes using all the attributes in a reference data set. And discovery by attribute, which search joinable attributes using a reference attribute. So to perform a discovery by data set, we will use the Next.js object and call the discovery method to pass as parameter a reference data set and a list of candidate data sets that we would like to search. As for discovery by attribute, we will have the same method, but we will need to provide the reference attribute that we would like to do, we would like to search. So here we have an example. We provide the candidate data set, the attributes discovered, and the quality that they provide, and the probability of the model. So we will prepare a demo in Apache Zeppelin. So let's go there. So here we are in Apache Zeppelin. We have two types of notebook. The first one that we will going to look is NestGD GUI. And this notebook contains 99 datasets and there are 621 attributes. Here we have a preview of the data. We can select another datasets from the repository. And in this side, we have the discovery type, discovery by dataset and discovery by attribute. We can select the quality. By default, NestGD only looks for high and good qualities. We can also choose moderate and poor. And in case we select discovery by attribute, we can select the attribute from the reference dataset. Here we have a discovery already done. We can see that we have the reference attribute and we perform a data discovery by dataset because we have all the attributes in the reference dataset. We have region, we have a store ID, capital, and others. So here we provide the candidate dataset and the candidate attribute with the predicted quality and the probability obtained from the random forest models. So here we have, so once that we perform a data discovery, we can select a candidate dataset. In this case, let's say that we are going to use marketing operations. And the reference attribute is region. So we will have to choose region that was the one that we discovered, and we can perform a join. A join will display the metrics for the join performed. We can see that the cardinality proportion is 0.664, which means that the cardinality proportion is close to the one that we have for region. We can see that the data set that we have here, 00.00 EMA data set, we have 9 distinct values, and the other has 14 distinct values. The containment similarity is 0.88, and here we have a new columns from the marketing operation data set. We can also check the attribute profile by clicking this checkbox, and will display the profile from the selected dataset. Here we have the frequencies. We can also obtain the entropy, the frequent words, the percentage by data type, alphanumeric, numeric, etc. So let's go to the other notebook. Here we have NestGD step by step, and we explain how to perform data discovery in Scala language. Here we have the setup, how to read data sets, how to make the profiling. Here we can see that we only need to call attribute profile, and here we display the profile that we obtain. We also explain the join discovery step and the qualities that we have. And the query by attribute, we can also see that we explain query by dataset. So here we explain step by step how to do it. As we can see, we need to call NestGD object dot discovery method and pass a reference or query dataset and a list of repositories. So that's it. So thanks for listening. To know more, please follow our website or feel free to contact us. Thank you.